Hi guys, welcome back. In this video I'm going to give you a quick overview of variables and how to initialize them, how to assign values to them, basically how to use them, and introduce you to couple of the different number variables that we can use in C++. And then I'll introduce you to the 5 basic arithmetic operators: addition, subtraction, multiplication, division, and modulus. Okay, and then I'll talk to you a little bit about integer division. Okay, a particular problem that you can run into if you're dividing integers. Some behavior that you might not expect. Okay, so I'll show that to you and give you a little heads up on that. Okay, so why don't we just go ahead and get started with variables in C++. Okay, so a variable is just a memory location or a location where we can store a value inside the memory of a computer, right? And these variables we can access and use for different purposes, and we can change them pretty much at will. Okay, so there are a couple of different types of variables that we'll talk about for right now. Okay, we can have an integer variable, we can have a floating point variable, okay, we can have a character variable, we can have Boolean variables. Okay, so if we want to create a variable that stores an integer in the computer's memory, then we have to specify two things. We have to specify the name of the variable, okay, also known as the identifier of a variable, and then we also have to specify its data type. Okay, when I talk about data types, I mean an int is a data type, a float or a double are data types, a char is a data type. Okay, so C++ is a strongly typed language, so we have to specify these things. We have to keep in mind what type of values we're storing inside our variables. Okay, so let me just show you really quick what that would look like. Okay, so let's say that I wanted to have a variable that stored an integer. Remember, integers are whole numbers. 5, 10, 12 are all integers. -10. Okay, they're whole numbers. No fractional part. No decimal places. Okay, so I can use whatever name I want for my variable, subject to a couple of rules. Okay, well, let me just show you what an int variable would look like. Oops. Int x. Okay, I've just defined a variable that I've decided to name x. Okay, and it is an integer variable type int. Okay, so this is an int variable named x. Okay, so the rules for what you can name your variables. Okay, rules for variable names. Okay, they have to start. They must start with an alphabetic character. That is to say, they have to start with lowercase a through z or uppercase a through z. Okay, you can't start them with an integer, for example. Okay, it has to start with an alphabetic character or an underscore. Okay, which is this character here. Okay, so lowercase a through z or uppercase a through z or an underscore. Okay, can't begin with digit or punctuation. Okay, what does that mean? That means that this is an invalid name. Here's some invalid identifiers. Okay, and an identifier is any programmer-defined name for something. Okay, in this case, variables. We're coming up with identifiers for variables. Identifier is just another way of saying name for something. Okay. So in valid identifiers, valid names for variables would be something like this: 9 dogs. Okay, that's invalid. Or exclamation point happy. Right, that's invalid. But valid names, okay, valid identifiers. Identifiers would be something like this: name, okay, or name, okay. But it's perfectly fine to use digits once you have begun the identifier with the lowercase or uppercase alphabetic character underscore. So you could do this. This is valid also. A9 dogs, that's valid also. Okay, that's perfectly fine. Okay, but you can't use any punctuation or any other characters other than that underscore. All right. So let's get back to the different data types. Right. So X can hold an integer. Okay. So I can do something like this: X equals 5. I've just assigned 5 to that memory location that I have named X. Okay, that's perfectly fine. I could define another integer. Okay, let's just call it Y, and initialize it to say 10. Okay, what do I mean by initialization? Well, when I define a variable, okay, if I assign a value to it at the time that I define it, what I'm doing is I'm initializing the variable. So in this case, Y, I've defined this variable Y, and I've initialized it to 10. Okay? All right, so integers you want to assign to int variables. Okay? Another common data type that we use in C++ and in other languages is the double. Okay? And a double is a data type for a variable that stores floating point numbers. Okay, so I could make double D and initialize it to 5.5. Okay, so that memory location will store the floating point number 5.5. Okay, so now I've shown you basically I've shown you two different data types and how to define variables and store them. Okay, so now what I want to do is I want to show you. Let me make a little comment here. Initial is variable D to 5.5. Okay. So what I want to do is I want to show you the arithmetic operators. Oops. Okay, so in C++ we have 5 operators. We have addition, right, which is a plus. We have subtraction, oops, which is a minus. But you would think that we might use X for multiplication. Well, that's not the case. Okay, X is a character. Okay, what we do is we use, in this language, we use an asterisk. In C++, asterisk is multiplication. Okay, and in many other languages too. Okay, for division, we don't have the division symbol on the keyboard that you're used to from arithmetic. So what they decide to use in C++ is a /. Okay, so that's division. Okay, and finally, the last operator we'll look at is the modulus operator. Okay, and modulus arithmetic is what you use when you want to find the remainder of something. Find the remainder. Okay, so if you were to divide 5 by 2, the remainder is 1. Well, modulus is what you use to find out what that 1 is. Okay, so that'll return the remainder. Okay, so let me show you how we do, or how we use arithmetic operators in C++. Okay, why don't I define this other variable here, sum. Okay. And now what I'm going to do, right now sum has got some garbage value in it. Nothing's been assigned to it. If you don't initialize the variable, there's nothing in it. Okay. So what I'm going to do is I'm going to add the contents of x and y together. Okay. And then I'm going to store that inside the sum variable. So sum is set to x plus y. Okay. So when I do this, what I'm doing is I'm using these variables. Whatever is currently stored inside x and y is going to be added together, and that result is going to be stored in the variable I named sum. Right. So in this case, x currently has 5 assigned to it. Y currently has 10 assigned to it. So x is going to be 5, right? And y is going to be 10. So 5 plus 10 is 15. So sum is going to contain 15 in it. All right. So I can use the cout object to display the contents of these variables. So let's do that to help us see the output of our sum. Okay. So we'll just do the sum of x plus y equals sum. Okay. Okay. So what's going to happen here with this cout statement? Well, what's going to happen is that cout is going to display the sum of x plus y equals. That's a string literal. Okay. And then it's going to append the contents of the sum variable to the end of this string. Okay, so what we're going to see when I run this is we're going to see the sum of x plus y equals 15. Okay, so let's go ahead and build this. Okay, and so there we go. The sum of x plus y equals 15. Right? So I could write that that way. Okay, so let's say now I want to multiply x times y. Okay, so now sum is going to be set to the product of x and y, and let me use cout again to show how things have changed. The product of, watch this, what I'm going to do is I'm going to just, instead of writing x and y here, I'm going to append the contents of x and y in here. Okay, x and equals sum. Okay, so what's going to happen here with this cout statement? Well, what's going on is that I'm passing this string literal, the product of, to cout. Cout is then going to display that to the screen. Then I'm passing the variable x to cout. Okay, so x is going to retrieve the value that's stored in the variable that I named x, and then append that to the product of string, right? It's going to show that on the output. Then it's going to go and grab this and string literal, and it's going to print that out to the keyboard. Then it's going to go to the y variable, and it's going to retrieve the value stored in there, which is 10. It's going to print that to the screen. Then it's going to show this string literal here, which is just a space, an equal sign, and a space, and then put that on the screen. And then finally, it's going to grab whatever's in sum, which in this case is going to be the product of x and y, and then display that to the screen. And then end line is going to move the cursor to the next line. Okay, so what we're going to see is the product of 5, because x contains 5, and y. Okay, and y, it's going to show a 10 on the screen because y contains the value 10, and then it's going to show equals, and then it's going to show 50. Okay, so let's go ahead and run that. Okay, so there we go. Okay, so the product of 5 and 10 equals 50. Okay, so now let's say that I wanted to divide two numbers, but I wanted to change the contents of x and y first. Well, I can set x to 10, right? Or let's think of something different. Let's 15. Okay. So I've just changed now what's being stored in the memory location that x is named for, right? So now x is no longer containing 5; it's now containing 15. Right? So now I'm going to change x to equal 3. Okay, or excuse me, y. So the memory location that y is referring to no longer holds 10 after this point. Okay, it's now going to hold 3. Alright, so now let's do some division. Sum equals x divided by y. Okay, so now when this line is executed, the sum memory location, right, the memory location that sum is referring to, is going to be assigned the value that's returned from x divided by y, from 15 divided by 3. So sum is going to contain 5. Okay, so instead of rewriting this thing here, well, let me show you a different. Instead of rewriting this thing, we'll just copy and paste it. Okay. 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 The result of x divided by y equals that. Okay. So now let's run this thing. Okay. So 15 divided by 3 equals 5. That's correct. Okay. All right. So, let me show you a problem that could occur if x and y don't divide evenly, right? If there is if there should be a remainder, or let's divide 5 by 2 and see what happens. Okay, let's do that. Okay, sum equal. Let's change x to 5, and let's change y to 2. Okay, then we'll just do sum equals x divided by y again. Okay, and then we'll display it. Okay. So what do you think is going to happen when I do this, right? Are you expecting to see 2.5? Right? 5 divided by 2 is 2.5. Should we be seeing that? I bet you think that's what we're going to see. Well, you're going to be surprised because we're not going to see that. Okay. Right? What we see is 2. Well, 5 divided by 2 is not 2. That's wrong. So what's going on here? Well, what's going on is that we are performing what's known as integer division. Okay? Integer division. In C++, when you divide an integer by an integer, what you get is an integer. Okay? The decimal places are truncated. They're lost. So 5 divided by 2, when you're dividing an integer and an integer, the answer isn't 2.5, it's 2. Okay, so how do we get the right answer? What do we do? Well, there's a couple things we can do, and perhaps the easiest thing to do is to just store 5 and 2 as doubles. Okay, so what if I was to get 2 more variables, or 2 new variables, say double A and B? Okay. This is another way that we can declare variables. We can declare variables all on the same line if we want to. Okay, so long as they're the same data type. All right. So what I'm doing now is I'm creating 2 new variables, A and B, and they're both double variables. Okay, they're both data type double. So what this means is that A and B now are going to be holding floating point numbers. They can hold floating point numbers. Whatever you assign to them is going to be stored as a floating point number. So let's say now that I assign 5 to A, and then I set B to 2. Now let's do our division now. The result of x divided by y equals. I'm not gonna do sum. I'm not gonna use this sum statement. I'm gonna do something different. Okay, just to show you that you can send an expression to C out. You don't have to just send a variable. So I can do this. This is perfectly fine. Okay, this syntax. What's gonna happen is I'm gonna print out the result of. Oops, I want to change this to A and B, don't I? Because these are different variables. Okay, so the result of what's stored in A, 5, divided by what's stored in B, 2, equals A divided by B. And this time it's going to be correct because we're no longer dividing an integer by an integer, right? We're dividing a double by a double. Doubles are a data type that store floating point numbers. So when we divide A by B in this case, we're dividing a double by a double, so we're going to get a double back. Okay, we're doing floating point division in this case. Okay, so let's run it. See what's going on. Okay, so there we go. Okay, this line here, okay, this corresponds to the integer division line that we saw, right? This part here. So, and we lost the 0.5. Okay, this last line of output corresponds to this here. Okay, and we're doing floating point division there, so that's why we don't lose the 0.5. Okay, so it's really easy in assignments and whatnot, or when you're writing programs, to forget this. Okay, if you forget and you just end up doing integer division, then what's happening is you're having a loss of precision, right? Your answer isn't as precise. This first line here, the answer is wrong, right? We're giving output that is incorrect. Okay, it's showing 2 when the answer should be 2.5. So this last line of output here, that's correct. All right. So let me show you. Well, I'll save that for a little bit later. We'll talk about promotion and demotion later. So let's put that on the back burner for right now. Okay. So the last thing that I think I'll show you is modulus. Okay, and modulus is just when we want to find the remainder. Okay, so see out the remainder of x divided by y is, x modulus y. Okay, so what this is doing, what this statement's going to say, this should say remainder, not remained. What it's going to say is, it's going to say, the remainder of x now contains 5, right, divided by y now contains 2, is x modulus y, which is 1, right, because 5 divided by 2, the remainder is 1, so we're going to see 1 there. Okay, so let's go ahead and run it to show you. Okay, C1, that's the remainder. Okay, so modulus can only be used with integer data types, right? If you try to find the modulus of, say, 5.2 and 2, you'll get a compile time error. Or if you try to find the modulus of 2 double variables, floating point variables, you're going to get a compile time error. Okay, so modulus only works for integer division, for integers. Okay, all right, so we're going to dig more into this. There's other data types, but I wanted to get your feet wet with the arithmetic operators, and also 2 different data types, integer data type and the double data type. Okay, we'll talk more about it in depth in class, but this little video, this short little tutorial, should help you get started, or should be useful as an example for getting started on the first homework assignment. Okay, so as always, if you have any questions, please feel free to shoot me an email or stop by my office hours. Otherwise, we'll see you later. Thanks for watching, and have a good night.